Okay, now let us flashback. Now we just see whether flashback can be performed or not. Flashback complete. When the flashback is completed, there should not be any entry in the recycle bin. It is empty. Recycle bin. Select is no rows. Select star from the database. It should display one record now. Yes, EMP IoT 1 is present. One record is present. That means flashback is present. Can we purge? Let us drop the table. Drop the table. Select star from tab. There is no data. Show recycle bin. There is one entry. Select star from recycle bin. Two entries are there. Now purge table name. Table purged. Select star from tab. Not there. Select star from recycle bin. Also it is not there. Entire data is removed from the recycle bin. Can we perform drop and purge together? Let us create a new table with EMP IoT 2. It is created. Select star from tab where table name equal to EMP underscore IoT 2. Yes, it is present. Select star from recycle bin. We don't have any data now. Drop table EMP IoT 2 with purge option. Table is dropped. select from the tab whether the table is present or not. It is not there. Select star from recycle bin, also not there. That means drop and purge is also working. There is no restriction. We can use purge option while dropping the table directly. Can we create normal index? Apart from the primary key index, unique index, can we create a normal index on the index organized table? Yes, index is created. There is no restriction. Can we add the constraints? Not null, check, all those things. Let us see with not null constraint. Primary key is mandatory, no need to check. So when primary key is allowed, not null is allowed. Unique is also allowed. There should not be any restriction. Or let us try with not null only. Yes, not null is allowed. Check constraint. Let us have one more column, manager. This is number, check manager in 1, 5, 9. We are using check constraint with IoT. Name we should change. This is 4. Yes, table created. Or let us give the names like not null, check, unique will work because primary key is already there. There should not be any restriction. Not null is working, check is working, unique also should work. IoT unique. Let us make ename as unique. Unique is created, no restriction. Primary key we have already tried, it is already there because it is mandatory. Now let us use foreign key. Manager, first we use self-reference, references, use fk of enum. using the self-referencing to the same table. It is allowed. FK1. Now this is referencing to the column of different table, not in the same table but different table. Yes, it is allowed. Foreign key is also allowed. So primary key we tried, foreign key self-referencing to the same table and different table, unique, check, not null. So all the constraints are allowed here. We don't have any restriction. And if you want to create the indexes, normal index is allowed, unique index is also allowed, because when we have primary key, by default unique index will be created. Let us have indexes now. Normal index we have already seen on IoT. Let us create unique index on, okay, we take this table, create index, index name on table of ename, create unique index, creating unique index. Okay, it is not EMP IoT check. I think this is 4. Yes, index created. Unique index we have created. Let us create bitmap index on IoT 4 of manager. 4, do we have manager? Yes. On manager column we are creating bitmap index. There is a restriction. Bitmap index cannot be created on IoT with no mapping table. Since there is no data segment, bitmap cannot be created. Let us create IoT 3 function based index sal into 2. We are using an expression, so it become function based index. Yes, function based index is created. Or let us create one more index 4 of upper of ename. Function based indexes are able to create. Bitmap index cannot be created. Unique, normal, function based. These indexes can be created. Let us create reverse key index. 4 of ename, reverse. We are creating reverse key index. Create index name on emp iot 4 of ename. Maybe the reverse should be inside. It is throwing error. Invalid option for index on an index organized table. Reverse key index cannot be created. So we cannot create reverse key index on index organized table. So these are some of the options we need to try on index organized table. Most of the indexes we have tried. Now let us see data dictionary views. Where do we get the information about index organized tables? Select table underscore name from dict. Dict is the synonym for dictionary. Dictionary is the complete name. Dict is the short form or synonym. Where table name like percentage index organized percentage, no row selected, maybe hyphen or something will be there, nothing. ORGANIZED, organized, nothing is there. IoT, Totally 33 tables are there here. Table name, table space name, cluster name, IoT name. EMP index is the table name, MVT, EMP normal, IoT FK1, IoT FK, this is IoT, select star from user underscore source where table name like percentage IoT percentage. Table underscore name, TABLE underscore name. What? Sorry, not user source, user tables. There are 6 tables. EMP IoT unique, IoT name is nothing, IoT type is IoT, this is the table name, we don't have any data dictionary view where we get the information about index organized tables, but from the user tables or user objects itself we can identify whether it is index organized table or not. See, under user tables we have a column IoT name. Here it is saying as IoT type is there. Yes, it is showing as IoT. That means it is index organized table. If you go to user objects, under user tables only tables will be there, user objects all will be there. Select star from user objects where object name like percentage IoT. There are 16 rows. Indexes also will be specified here because index is also an object. Object name is EMP IoT, and then sub object name, object ID, data object ID, object type is table, created, last DDL timestamp, status TGS, temporary generated secondary. Here it is showing as only table, and then if it is index it is showing as index. We have 6 tables and 10 indexes, I think. So under user tables only we can identify based on the IoT type column. If the IoT type is saying as IoT, then the table type is IoT, index organized table. See here, EMP IoT 4, IoT type is showing as IoT. That means it is index organized table. So we do not have any specific data dictionary view for index organized tables. Under user tables only, all the index organized tables will be listed out. Now we have seen most of the features with index organized tables. Now let us see the differences between normal table and index organized table. Differences between normal table and index organized table. Let us see the differences one by one. The first one is normal table or heap organized table. Heap organized table is nothing but normal table. Normal table and index organized table, IoT. So in case of normal table, row ID uniquely identifies a row. But in case of index organized table, primary key itself will uniquely identifies a row, because primary key is mandatory in case of IoT and primary key is optional in case of normal table. That is why to identify a record or a row uniquely, we use row ID in case of normal table and we can use primary key column in case of IoT. So primary key constraint is mandatory in index organized table, primary key constraint is optional in case of normal table. It is not mandatory. To build secondary indexes, physical row IDs will be used in case of normal table. For the same secondary indexes, logical row IDs will be used in case of index organized table. By using row IDs, we can access the individual rows directly in case of normal table. Those individual rows can be accessed indirectly by using primary key also in case of index organized table. Because primary key is mandatory, using primary key itself we can access the individual rows here. To access the complete data from the table or all the rows from the table, we use full table scan, sequential full table scan in case of normal table. And in case of index organized table, we use index fast full scan, either full index scan or index fast full scan, fast full index scan. So for accessing all the records, index may or may not be present on the normal table. So it will go for full table scan, sequential full table scan. But in case of IoT, since primary key is present, unique index is already present in that. That is why it will go for index full scan, full index scan or fast full index scan. Normal table can be stored in a cluster with other tables also, but IoT cannot be stored in a cluster. So we cannot store index organized tables in clusters. Normal table can contain long columns, long row columns and LOB columns, but IoT, index organized table, can contain LOB columns, but it cannot contain long column or long row column. LOBs are allowed in IoT, but long columns are not allowed into IoT. Normal table can have virtual columns, which is introduced in 11G. But IoT cannot have virtual columns. We cannot use virtual columns, we cannot use long columns, we cannot use long row columns in IoT. Rest all other data types are allowed. All LOBs are allowed, no restriction. IoT cannot be stored in a cluster. These are the differences between normal table and index organized table.